Hello, PreCalc. You're watching this after Thursday's class. It is February 2nd, or since we're not meeting on Friday, you may be watching it on Friday the 3rd, Saturday the 4th, or Sunday the 5th. So many choices. We're going to play a game that's sweeping the country. It's called What Conic Section Is This? This is the icing on the cake of our conic section study. What I'm going to train you to do today is look at an equation and tell me what conic section it is. What do I mean by conic section? Well, before I reveal this, let's review that. Conic sections are the shapes that we have been studying recently. We started with the circle, then the parab, and then the ellipse, and the hyperb. Alright, so I'm going to give you an equation and ask you to just look at it and by quick inspection tell me which of the conic sections it is. Alright, so here's the most general form of an equation, and we gave you that of conic sections. Equations, the general form for the equation of a conic section. Now, this was given earlier, so you see that in your comp book. But notice I mentioned back then that I conspicuously left out the B term. Well, I think you can bear it now, so I will reveal that there can be a B term. This year we will not deal with the B term, but if there is one, it's the BXY term. So now you know. And if you're good and attentive, and I remember, I will tell you what the XY term does, although we will not deal with it. Alright, so that's the general equation. Write it down again. And now we begin your training. So the first thing, if there is only one squared term in your equation, so suppose you had 4x squared plus 3x minus 2y plus 7 equals 0. Say you had something like that. There's only one squared term, and that's x squared. That would also work if this one squared term was y squared. So if that's the case, if there's only one squared term and the other squared term does not exist in your equation, then you have the parabola. Alright, one squared term is the key to that. Alright, what about another scenario? What if there are two squared terms? So we took care of parabola. What if there are two squared terms? So you're going to have an x squared term and a y squared term. And this time their coefficients are equal. Maybe you noticed that when we were working them. So say we had 4x squared plus 4y squared minus 3x plus 2y minus 15 equals 0. Notice we have an x squared term and a y squared term, but the coefficients, the numbers in front, are equal. That it also includes if they're both negative. Still, they are equal, so the number in front is both x squared and y squared is -4. That also qualifies for this case. And that scenario, that is a circle. Alright, our training continues. Alright, what if there are two squared terms and their coefficients are not equal, but they have the same sign? So what's an example of that? Let's say we have 5x squared plus 7y squared minus 3x plus 2y minus 15. Not very creative, am I? Alright, so here we have an x squared term, we have a y squared term. Their coefficients are not equal, so we don't have a circle but they have the same sign. They're both positive. And that would also work if they both were negative. So either of those cases, we have the mystic ellipse. All right. And last case, I think you know what's coming since we already covered circle and ellipse. Let's talk about it. Anyway, there are two squared terms, so we have x squared and y squared, and their coefficients are not equal, but have opposite signs. So up here, the coefficients of x squared and y squared were not equal, and they had the same sign. Now they're going to have the opposite signs. So maybe I will have a negative 3x squared and a positive y, say 2y squared minus 3x plus 2y minus 15 equals 0. All right, so this time we have coefficients that are not equal to the squared terms, but their signs are opposite. One is negative and one is positive, and that would work the same if this one, the x squared term, was positive and the y squared term was negative. All right, and that is the happy hyperbola. All right, so let's see if you can put that together and tell me, without a shadow of a doubt, what kind of conic section is represented by this equation? All right, so I will count to 5 while you answer it. 1, 2, 3, 4, 5. Write down your answer. Because it has only one squared term, the y squared term is missing, we know in that case it is indeed a parabola. All right, the next equation has this. Write it down. These are 4 examples that you can study later for like the final or for the next test or for mathematical enjoyment. All right, I will count to 5. 1, 2, 3, 4, 5. All right, so your answer, please. You notice there's an x squared term and a y squared term. Notice that they are both the same number, coefficients. So therefore, that happens with the circle. All right, the last 2. So this one, jot it down. And I count down from 5 while you evaluate it. Counting down from 5. 5, 4, 3, 2, 1. Your answer, please. All right, here we have an x squared term and a y squared term, but they have different coefficients in front, and they have different signs. So this one's positive, that one's negative. So we definitely are looking at the hyperbola. And lastly, we have this one. After you write it, go ahead and endure the countdown. 5, 4, 3, 2, 1. Your answer. And hopefully you saw that they has an x squared term, a y squared term. They're not the same number, and they have the same sign. They're both positive. We have an ellipse. All right, that's the kind of thing I'll be expecting you to come with on Classel Monday, where we will put the icing on the cake of our conic section lesson. All right. enjoy, and we'll see you on Monday. Enjoy your weekend, and see you on Monday.